guys, maybe missed class yesterday, so I'm going to go through this note sheet with you real quick. When geologists are trying to make maps for each other, they will use symbols to represent the different types of rocks that they're most likely to come across. So what I'm doing is I'm just giving you an overview of the different sedimentary symbols. Limestone, remember, is calcium carbonate. Shale is mud that's been compressed. Sandstone is silicon dioxide, it's quartz. So geologists all recognize these symbols, and then they don't have to write the words out. They can just draw a diagram and put the right code in. Conglomerate, remember, is gravel. It's been rounded, so we have rounded pebbles that are kind of large with a fine grained background. Igneous rocks, anything that comes from magma or lava, but generally we're talking about undergrounds, we're talking about magma. Those are represented by crystals or X's. And then metamorphic, remember, is usually recognized as foliated. So we have wavy lines that are parallel here for metamorphic. So you can use these symbols in your diagrams, and geologists will know what you're talking about. We talked about the principles of relative dating in class. The first thing we have here is James Hutton. James Hutton is known as the father of geology. The reason people call him that is because James Hutton ushered in a new era of using common sense, thinking about the world around us in terms of, hey, this sequence of rocks looks like something that I've seen before, so I could probably decode it the same way. Instead of coming up with dramatic events like mega floods, or mega hurricanes, or catastrophes, he ushered in the age of uniformitarianism, which is a philosophy. So this is a philosophy. It basically says, let's use common sense when we're decoding the past, and the slogan is, the present is the key to the past. What this means is, the processes working today can be used to explain geologic phenomena. Or the geology around us. By processes, I mean things like volcanoes, earthquakes, weathering, and erosion. James Hutton came up with all this back in the 1800s. So that was before plate tectonics. So there's really no, subduction or rifting, all the things that we associate with plate tectonics and seafloor spreading. But still, even back in the 1800s, he could look at the Grand Canyon and say, I believe this canyon formed from a slow river coming through, carrying the sediments out little by little, rather than a mega flood washing the whole canyon out in one night. So the 1800s is when geology really started to use common sense. Uniformitarianism became the mindset. We'll think about what's going on in the world around us today and use that to explain how things happened in the past. There are 4 principles that we're going to use to guide us in our decoding the past. The first is the principle of superposition. It's a simple idea that the oldest rock layers are always on the bottom when you're looking at a sequence of rocks. So if I came across some layers and I had, let's say, sandstone, and I had some shale, and I had some conglomerate, and all that is underground, common sense tells me that sandstone was there first. Because all those sedimentary rocks are deposited underwater. If you go and pour sand out in the lake, it's going to smooth out, make a flat layer. If you pour some mud out, it's going to smooth on top of that, but not sneak under the sand. Same thing with conglomerate. So superposition is a very old idea, going back to the 1600s, that you're going to use common sense and say, the bottom layer is the oldest, the youngest is closest to the surface. It's the most recently deposited. The next one is the principle of original horizontality. Original horizontality is the idea that Layers are deposited in a horizontal position. They're flat. That's because we're talking about sedimentary layers. Mud, sand, gravel, even limestone will all be formed from sediments that settle out in water and lay flat. So we're talking about flat layers. And if you find them, they're no longer flat. And if they're tilted or folded, it means that happened later. Next is the principle of cross-cutting relationships. Cross-cutting relationships is the idea that if you have a fault or an igneous intrusion cutting through rock layers, the fault or the intrusion came later. So in order to have a fault cut through layers, let's say you have those same layers as before, but a fault came through and now they're disjointed. So we still have our sandstone and our shale and our conglomerate, but over on the right side of that fault, the sandstone has been lifted up a little. The shale lifted up a little. So they don't match up anymore. That fault would have come after the layers had originally been deposited. Otherwise, you have a fault extending into air. And then sediments would deposit around that. And that would be magic. That's not reality. So cross-cutting relationships, anything that cuts through the rocks is younger than what it cuts through. The last one is the principle of inclusions. This is saying that if you have pieces of one rock within another rock layer, those pieces are older than the layer that contains them. Think of it like chocolate chip cookies. The chocolate chips have to exist before you can put them in the cookie dough to bake the cookie. So when you're eating a chocolate chip cookie, you know that those chocolate chips existed longer than the cookie itself, but they're included in it now. They're part of the cookie. That's how inclusions are. Maybe you think about conglomerate with all of its gravel. The gravel has an older story. Before it was conglomerate, it was something else that broke down. So I'm going to draw a little diagram. And the thing about this diagram is I would have to erase. So what I'm going to do is I'm going to pause, draw the diagram, and come back to you. Alright, so you can see my diagram. Over here we have a red intrusion. Here we have two inclusions. The inclusions are sandstone, but they're in a layer of shale. So I'd be like, hey, where did the sandstone come from? But if I look below, there's sandstone in that bottom layer. So if I was going to put an order to this and say what happened first, second, third, I would say the sandstone was first. And it made those little inclusions. They got broken off and incorporated into this shale layer. That limestone, that came later. This intrusion cuts through both the sandstone and the shale. So we definitely know that intrusion is younger than the sandstone and shale. It doesn't cut through the limestone, so we can't be sure. But in this case, I'm going to say that that happened last. So that's how you would decode things. I use superposition to figure out the order of the layers. I use the principle of cross-cutting relationship to figure out that this intrusion is younger than the layers it cuts across. The principle of inclusions tells me that these rocks that are included in the shale are older than the shale itself. So that's what we covered the first day.